Hello, and welcome to this presentation on solving quadratic equations. Quadratic equations have the generic form of ax squared plus bx plus c is equal to 0. In numerical form, that could be something like 2x squared minus 10x plus 8 is equal to 0. Quadratics plot the shape of a bucket, as shown here, or a hat, an inverse shape. They're often called parabolic shapes. There are various methods of solving quadratic equations to find what are called the roots. These are the roots of the equation where the curve crosses the x-axis. We will look at two methods in this presentation. One using the method of factors, also called factorization, and a second method is using the quadratic formula shown here on the right hand side. Please note that no contextualized questions will be solved within this presentation. There is a separate presentation to look at applications of quadratics where descriptive and contextualized questions are considered. Brief introduction. Engineers often solve mathematical equations using various standard methods. Within a previous presentation we looked at solving what are called simple equations, something of the form 3x minus 12 is equal to x minus 2. In a simple equation there is only one unknown. There's one value to be found for the one unknown. In the above equation the unknown is x. Using the language of mathematics, a simple equation has one root. So one value of x means one root. In this presentation we're going to consider the solution of quadratic equations. Now a quadratic equation is one that contains a square. For example, it could be x squared, it could be 3t squared, it could be 3 theta squared. The variables can change. But there's no higher power than the squared term for the unknown quantity, the x, the t, etc. So quadratics contain two roots, as the equation includes this second power, this squared term. So when you're solving quadratics, there are always two values, two solutions, two roots, which when squared produce a number. So for example, given x squared is equal to 9, then x is equal to the square root of 9. And don't forget, whenever we're taking a square root, there are always two solutions. And the solutions here are positive and negative 3. So be careful. When you square root a number, there are always two solutions. Just to clarify that for you, when you square root 9, positive 3 multiplied by positive 3 is equal to 9. But also negative 3 multiplied by negative 3 is also equal to 9. This double negative effect here gives a positive answer. So there are two solutions. So the roots of a quadratic, they could be different, they could be equal as shown above, or one of them could actually be 0. Just for reference, there are quadratics that do not have any real values, and these are called complex solutions, and they're dealt with in a separate presentation on complex numbers. For reference, in the above sketch, we have two roots to this equation. The roots occur where the curve crosses the x-axis. So one root occurs here as a positive value of x, and the second root occurs here, in this case, a negative value of x. Note also that the generic form of a quadratic equation is ax squared plus bx plus c equals to 0, where the c is equal to the intercept of the quadratic curve with the y-axis. It's called the constant c. And also the lowest point on the curve, in this case the minimum value, is termed the vertex. There is also a vertex at the top of the curve if the parabolic shape is inverted. So here's a typical quadratic equation of the form ax squared plus bx plus c equals to 0. In this case we have 6x squared plus 7x minus 5 is equal to 0. This has been solved graphically here. What we've done is basically plotted the equation. Here's the equation here. We plot x on the horizontal axis. These are x values. They're plotted on the horizontal axis. And we plot the y values on the vertical axis, on the y-axis here. And that plots this quadratic shape shown here. This is the shape of a bucket. They can also be in the shape of a hat, and others reversed. This is the bucket shape. So as mentioned previously, when you're solving a quadratic equation, there are always two solutions or two roots. and the roots are denoted here. There's one root over here, a root there, and another root here. So by inspection of the above graph that's been plotted, we would estimate the roots to be at x is equal to 0.5 and probably x is equal to negative 1.6. If we were to solve for the two roots analytically using the factorization method or the quadratic formula, we would actually find the roots are at x is equal to negative 1.6 recurring, or negative 1 2/3, and also at x is equal to 0.5. And that's one of the benefits of the analytical techniques of factorization and the quadratic formula, is they give you the exact values. When using the graph, although nice and visual, it's not always easy to interpret the actual values for the roots. The following slides now will start to review the factorization method and the use of the quadratic formula. So there are various methods of solving quadratic equations. Firstly, we could plot the graph as shown on the previous slide and note where the curve crosses the x-axis. That will find the roots for us. We could also use something called factorization, or method of factors, which we're going to look at in a moment, and also we could use the quadratic formula. Again, we'll look at that one later on. The quadratic formula is actually shown below. You may have seen this before. X is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. Another method we could use is called completing the square, but I'm not going to review it in this presentation. There's a separate presentation on completing the square. The first method above here is called a graphical technique, but methods 2 and 3 shown here, factorization and the formula, are classified as analytical methods. So let's solve quadratic equations using factorization. When you become proficient at this method, solving quadratic equations using factorization can be a quite quick process. But we tend to only use it where we can factorize the equation into whole numbers. So let's look at factorizing expressions of the form ax squared plus bx plus c. Note that the a, the b and the c will be integers in these cases. I've given you a few basic steps here to consider when solving quadratic equations using factorization. We don't necessarily use all these steps in all the questions or the solutions, but they're useful as a reference guide. So the first step to consider is the equation of the form ax squared plus bx plus c. Not all equations will be given directly in that format. So we may need to rearrange the equation into the generic format of ax squared plus bx plus c if it's not given in that form. Step 2, we should divide throughout by any common factor to help simplify the numbers. Again, not all questions will require this. Some may be in their simplest form, but there may be, say, a factor of 2 that each term a, b and c could be divided by to reduce the order of the numbers. And again, if we can spot that, then it makes the arithmetic easier in the factorization process. Now step 3 is interesting to note. If the constant term, that's the c in the above equation, is positive, then the sign in each of the brackets we're going to use in the factorization process is the same as the sign of the coefficient of the x term, and that's the b value above. So if, for example, our constant c was positive 6, then it means the sign in the brackets will both be the same, but they'll be dependent on the sign of constant b. So if constant b was negative 3, for example, then they would both be negative signs in the brackets. We'll try and highlight that in the questions we will look at when we're factorizing quadratics. And finally, step 4, if the coefficient a has a value of 1, so we just have an x squared, then the numbers in the two brackets actually multiply to produce the coefficient c, and they add up to give the value of b. And we will highlight this consideration in the examples we're going to look at when we solve quadratic equations using factorization. Okay, example 1f is an illustration of using factorization to solve a quadratic equation. This time it's given us the form 2x squared minus 10x is equal to negative 8. So I'm going to try and follow the steps through from the following slide to give a structure to my solution. So in step 1 we have to consider the format of the equation. Is the equation given in the format of ax squared plus bx plus c is equal to 0? And looking at the above equation here, no, it's not. It's actually ax squared plus bx is equal to c. So I need to rearrange the equation first of all. I'm going to add 8 to both sides of the equation to get the constant from the right hand side to the left hand side. So I'm going to start from the equation 2x squared minus 10x plus 8 now is equal to 0. I've added 8 to both sides of the equation. Now I have the form ax squared plus bx plus c equals to 0. I must always have that form. Step 2, we need to consider the equation and see if there's any common factors that we can divide throughout by to simplify the numerical work. And there is in this case. There is a common factor of 2. Each of the terms in this equation here can be divided by 2 to simplify the numbers. So dividing the first term by 2, 2x squared divided by 2 is 1x squared. We don't write the 1 but it's there. So that's 1x squared. Then negative 10x divided by 2 is negative 5x, and 8 divided by 2 is 4. Obviously 0 divided by 2 is still 0. Now step 3 states that if the constant c is a positive value, which it is in this particular case, then the sign in each of the brackets that we're going to form is the same as the x coefficient sign. Now in this case the x coefficient sign is negative. So that means the sign into the brackets we will use will be negative. Now in this technique I'm going to show you, I'm going to use a little tabular form. And what we do in the left hand column of this table here is we write down factors of the x squared term. So we have 1x squared in the equation above. So factors of x squared would be x and x. So that's simply 1x and 1x there. Now in the second column here, I'm looking for factors of the constant c term. So factors of 4 could be 4 and 1. 4 times 1 is 4. Or of course it could be 2 times 2. 2 times 2 is 4. Whatever pair of factors I use, they must be negative here because the constant c is positive and the constant b is negative. So they've got to be negative values. And I've chose to use negative 4 and negative 1 in this particular case. I cannot use 4 and 1. I know that's going to give me the wrong answer. But I could use negative 2 and negative 2. But I'm going to try negative 4 and negative 1 here. Now what I'm going to do with this method is I'm going to use a cross multiplication approach here. And you must stick to this. Now in this particular instance, because factors of the x squared term are the same, I don't really need to cross multiply. But I'm going to keep that process going because in later questions we will need to cross multiply. So I'm going to stick to that process throughout. But I realise you do not actually need to cross multiply in this particular case. So considering the cross multiplication process, what we're going to do now is multiply the x by the negative 1. That will give us negative x. So I've cross multiplied these two values. Then I'm going to cross multiply the x by the negative 4. So I'm cross multiplying these two values and that's shown there. So negative 1 x minus 4x in this case would be negative 5x shown here. Now if that's the middle term we're looking for, then we already have our factors. And it is because from our equation above we now have the middle term, the negative 5x. So we have our factors straight away. That was a good guess, if you like, in this case. So now to state the factors of the equation, we read horizontally. So that's x minus 4, shown here. And that's going to be x minus 1, and that's shown here. And those are termed the factors of the equation. In other words, we factorise the quadratic x squared minus 5x plus 4 equals to 0. We factorise that into x minus 1 and x minus 4 brackets there. But don't forget, when we're solving quadratics, what we're really after is the roots of the equation, and that's where the curve crosses the x-axis. And I've got a little diagram here of the curve, and it's crossing the x-axis there, that's actually at positive 4, and it's crossing the x-axis there, and that's positive 1 on the graph. So that's what we're actually trying to find. So we found the factors in this factorisation process, but that's not completed the solution. We need now to find the roots. So to solve for the roots, I simply take each of the factors and equate them to 0. So taking the first factor above, which was x minus 1 in the bracket, I equate it to 0, and I solve this simple equation to find x. In this case, just add 1 to both sides of the equation, and x is equal to positive 1. In the second factor above, that was x minus 4, I simply equate that to 0 and solve that. Again, simple equation, add 4 to both sides, and I will solve it. So x is equal to positive 4 in this case. And those are my roots, and as I said, they're shown on the diagram above. The curve crosses the x-axis at positive 4 and it crosses the x-axis at positive 1. So those are the roots to the problem. Exercise 1F here. We're given 3 little questions A, B and C to solve. If you feel you can solve these questions without further assistance, I would strongly encourage you to stop the presentation now and attempt these questions. The answers, the roots here, are given on the right hand side in the brackets. If you require further assistance, then on the following slide I will work through these solutions in detail. Okay, I worked through these questions using factorization. So question A. We are given the equation x squared plus 12 plus 8x, and that's equal to 0. So basically all the terms are on the left hand side, which is good. They're not quite in the order I want. I really want them in the form of ax squared plus bx plus c is equal to 0. So just for completeness, I'm going to slightly rearrange the equations. So I'm going to write that as x squared plus 8x plus 12 is equal to 0. Now I have my form of ax squared plus bx plus c is equal to 0, it's just looking for. So I cannot divide by any whole numbers here to simplify the equation further. So that's my equation to solve, the x squared plus the 8x plus 12. I'm going to use my little tabular method here to help with the solutions. So in the first column here I put factors of the x squared term, so that's 1x squared here, so that will be x in x, because x multiplied by x is x squared, so the factor of the x squared term, so that's what's in this column here. And the second column I put factors of the constant 12. Now there are several factors I could use here. I've got 12 in 1 I could use, I've got 6 in 2 I could use, I've got 4 in 3 I could use. So I've got a variety of factors here. So some of you may see instantly what factors to use in this particular case, but it's basically a trial and error process if you're unsure. Now because the constant 12 is positive, I know that the signs in both of the brackets are going to be the same, and because I've got a positive for my constant b, my positive 8 here, I know they're both going to be positive. So I'm going to try in this case 6 and 2. So 6 multiplied by 2 would give me 12. So my factors of 12 shown here in this case 6 and 2. To keep the process consistent, I'm going to cross multiply these two values in this case and add them up. So cross multiplying, I get x multiplied by 2, so that's 2x, and I get x multiplied by 6, so I add to that the 6x. What does that give me? That gives me 8x. Is that the middle term that I'm looking for? Positive 8x here? Yes it is. So I've got the solution straight away here. If you had tried numbers of say 4 and 3 for example, you would have ended up with 7x, and obviously that's not correct. So now I can write down my factors from above, and we read horizontally in the table to find the factors. So the factors in this case will be, put them in brackets, x plus 6, so that's a factor there, x plus 6, and also a factor of x plus 2, which is this factor here. So we found the factors, but of course we really want to find what the roots of the equation are, the actual solution. So to find the roots, we simply take each of the factors individually. So take the first one, x plus 6, we equate it to 0 and we solve it. So therefore in this case, subtracting 6 from both sides, x is equal to negative 6, so there's one root, and taking the second bracket we've got the x plus 2 is equal to 0, and again subtracting 2 from both sides, x is equal to negative 2. So there's our second root here. So the solutions are x minus 6 and x minus 2. We can see from the answers we've got them correct. Part B here, we're given the equation x squared plus 6 is equal to 5x. That's not in the form we need the ax squared plus bx plus c format. So subtracting the 5x from both sides of the equation, I will get x squared minus 5x plus 6 is equal to 0. I've again got my form of the ax squared plus my bx plus my c is equal to 0. I've got that generic form. Now I'm going to use my little tabular method to find the factors. So the factors of the x squared will again be x and x in this case. And then factor of the constant. Now 6, I've got factors of 6 in 1 I could use, or 3 in 2. I only use whole numbers to try and find the factors, so that's my options there. But notice the constant c is positive, so that means the sign of the brackets are the same. But because the constant b is negative, it's negative 5 here, that means they'll both be negative in this case. So because I'm trying to make 5 here, what I think I will do is use 3 and 2. So 3 multiplied by 2 gives me a value of 6, so that's the constant. But don't forget they need to be negative 3 and negative 2 in this case, because I've got negative on my b term in the equation. So again, using the cross multiplication process, I'm going to cross multiply the value. So x multiplied by negative 2, that gives me negative 2x. And then x multiplied by the negative 3, that gives me negative 3x. So I'm taking away 3x. And evaluating, I get negative 5x. Is that what the middle term is? Yes, we can see it clearly is. So I've solved for that one. So that means my factors then, just reading horizontally across, is x minus 3. I'm reading horizontally across here, be x minus 2. I need to find the roots, of course, as always. So I need to equate each of the factors to 0. So x minus 3 is equal to 0. So adding 3 to both sides, x will equal to positive 3. And also x minus 2 is equal to 0. So again, adding to both sides, adding 2 in this case to both sides, x is equal to positive 2. So there are my roots, and again I can see from the solution it's 2 comma 3, so that's 2 and 3 are the solutions here. So we've got the correct solutions again. So there are my solutions to the equation. And finally part C of this exercise, I'm given the equation x squared minus 6x is equal to the negative 9 on the right hand side. Again, that's not quite in the format I want, so I'm going to bring the negative 9 from the right hand side to the left hand side. So I'm going to add 9 to both sides here. So I'll start from the equation x squared minus 6x plus 9 is equal to 0. And again, I've got my ax squared plus my bx plus my c equals to 0 format. Going through my factorisation process, I need factors of the x squared term. So again, we know it's going to be x in x, so there's nothing new there at the moment. So factors of 9 could be 9 in 1 or 3 in 3. Again, I've got a positive value for my constant c here, but a negative value for my constant b. So that means the signs are both going to be the same, and they're both going to be negative. I'm going to use negative 3 and negative 3 in this particular case because I think that's going to work quite nicely for me. So trial and error really, a bit of experience, use of tables is also helpful when you're factorising. Again, keeping a nice consistent process here, I'm going to cross multiply here, so x multiplied by negative 3 is negative 3x, and here x multiplied by the negative 3, that's subtracting 3x there, so that's negative 6x when I evaluate that expression. So the factors, just reading horizontally across, I will get x minus 3 and x minus 3. Again, I need to find the roots of the equation, so let's find the roots now. So the roots, just equate each of the brackets to 0 and solve. So x minus 3 is equal to 0, so clearly x is equal to 3. And of course in this particular case, both brackets are exactly the same. So our two solutions, there's always two solutions, are actually the same value. x is equal to 3 in this particular case, and that's shown in the answer up here. Okay, so now we can see that all the questions have the correct solutions. So part A we know was correct. Part B, I should have x is equal to 3 and x is equal to 2, and that's what's shown here. And in part C of the exercise, I should have x is equal to 3 and x is equal to 3, and of course that's what's shown here. So I've solved for the roots in all three of the equations given. Just to try and illustrate what the equal roots mean here is if we draw an x and a y diagram and we plot our curve, we would find that the quadratic curve comes to the x-axis and just touches it at the x is equal to 3 position there. So our two roots in this particular case are the same. They occur when x is equal to 3. And just adding sketches to show the roots of the solutions for the other equations. So in part A here, the roots were at -2 and -6, so the quadratic will be shown on the left hand side against a bucket shape. And for part B of exercise 1F, the roots were shown to be x is equal to 2 and x is equal to 3, so the sketch of the quadratic would look something like that. Again, it's another bucket shape. Just going to take you through another example of factorization, example 2F. They changed the variable here from x to t in this case, but that doesn't bother us in the way we approach the solution. We're given the equation 4t squared minus 27t plus 18 is equal to 0. Slight different here that the a coefficient associated with the squared term is no longer 1, so that just slightly complicates the solution sequence. So just considering little steps we had on the previous slide. Step 1, the question is already in the right format, so it's stated in the form of ax. So just thinking through the steps we had in the previous slide. Step 1, is the equation the format ax squared plus bx plus c? Yes, it is. It's of the form of 4t squared minus 27t plus 18 is equal to 0. So that is in the form of ax squared plus bx plus c. Just noting that x in this case is actually t. So the variable changed there, the symbol's different. Considering step 2, there are no common factors to divide throughout by. In this case, we cannot divide 4, negative 27 and the positive 18 by any whole number to simplify the numbers further, so it's got to remain as it is. And considering step 3, the constant c in this case is a positive value, it's positive 18 here, so that means the sign in each of the bracket will be the same as that for the b coefficient, so in this case they'll both be negative because I've got a negative 27 for my b term. So I'm going to use the same tabular approach as we used in the previous question. The only thing that's slightly complicated now is that the factors of the x squared term, or the t squared term in this case, can actually be various values. They're not just going to be x and x, or t and t in this case, but we could have, for example, 2t and 2t, because they're both factors of 4t squared, or we could have 4t and 1t, because again they're factors of the 4t squared. So we've got slight variation now we could have with factors of the effectively x squared terms here. But I'm going to use the same approach as in the previous table. So first of all, I'm going to try factors of 4t squared being 2t and 2t, because 2t and 2t multiply together to give you 4t squared. So they're definitely factors of 4t squared. I'm looking at factors of the constant 18 here. So I want two numbers that multiply together to give me positive 18. Now don't forget they've got to be negative values in this case because we've got a negative value for the b coefficient, negative 27. But I've got quite an array of factors I could use to make positive 18 for my constant. I could use the negative 18 multiplied by negative 1, that's positive 18. I could use negative 9 multiplied by negative 2, that's positive 18. And I could use negative 6 multiplied by negative 3, because that's positive 18 also. So 2t multiplied by, in this case, the negative 1, the negative 1t would give me negative 2t, and then the 2t cross multiplied with the negative 18, shown here, would give me negative 36t. When I add them together, negative 2t take away is negative 38t, and that's not correct. That's not the middle term. I'm looking for negative 27t, so that's not correct. So those factors didn't work. Now I can try the next factors of the negative 9 and negative 2. So next I'm going to cross multiply the 2t with the negative 2, so that gives me the negative 4t shown here. Then I'm going to cross multiply the 2t with the negative 9, that gives me negative 18t. Add them up, that gives me negative 22t, so that's still wrong, that's not my negative 27t I'm looking for. And I can do the same with the last factors, but again I will see that I will not get the negative 27t. So none of those factors work there. And that's because the 2t and the 2t are not the factors I'm looking for the 4t squared term. I'm actually looking for factors of the 4t squared term to be 4t and 1t. So now using 4t and 1t, and I'm going to try factors of the positive 18, first of all to be the negative 6 and negative 3, that multiplies together to give me positive 18. So cross multiplying, 4t multiplied by negative 3 is negative 12t, and 1t multiplied by negative 6 is negative 6t. Add them up, I get negative 18t, but that's not what I'm looking for because I want negative 27t. So in this case what I've done is swap them around. I've actually put the negative 3 now on the top line and the negative 6 on the bottom line, because that makes a difference now because I've got different values for my factors of the 4t squared term. So it makes a difference in which way round you position the factors of constant c in the table. But now cross multiplying the 4t with the negative 6, I get negative 24t shown here, and cross multiplying the 1t with the negative 3, I get negative 3t shown here. When I add them up, I get negative 27t, and that's what I'm looking for, the negative 27t. So now I've found my factors at last. Don't forget, we always read horizontally to find the factors. So reading horizontally, the factors will be 4t and negative 3, so that's factor there. And again, reading horizontally, the factor will be 1t and the negative 6, and that's shown here, t minus 6. So we now find our factors. As always, we want to find the roots, so we've got to create each of the factors to 0 in solve. So to solve for t, we add 3 to both sides and we divide both sides by 4. So t in this case will be 3/4, 3 upon 4, 0.75. And taking the second bracket, the t minus 6, equate that to 0. We add 6 to both sides, so in this case t would be equal to 6. And those are our solutions. So a slightly more complicated solution here, because the factor of the 4t squared could be, in this case, 2t and 2t, or they could have been 4t and 1t. Exercise 2f, we're given 3 equations here to solve using the factorisation process. Again, if you feel confident enough to attempt these questions without further assistance, please feel free to stop the presentation now and attempt the questions. The answers are given in the brackets on the right hand side, these are the roots. If you require further assistance, then I will work through these questions in detail on the following slides. Okay, question A, we're given the equation 3x squared plus 10x is equal to negative 8. So again, we've got to get it into the right format first of all. So adding 8 to both sides, we will start from the equation 3x squared plus 10x plus 8 is equal to 0. Again, that's sort of form ax squared plus bx plus c equals to 0. So factor the 3x squared term, well, we can only use 3x and 1x in this case. No other whole numbers we can use. Now noting that the constant c here is a positive 8, that means the signs in the brackets will both be the same, and as we've got a positive b value or positive 10, they'll both be positive signs. Factors of the 8 could be 8 and 1, or it could be 4 and 2. I think I will use 4 and 2 in this particular case, and I'll write it in terms of 4 on the top line and 2 on the bottom line. As usual, you'll cross multiply here, so 3x multiplied by 2 is 6x, and we add to that in this case the 1x multiplied by 4, so we're adding the 4x. That gives us 10x, and that's the middle term, so we've got the right factors here. So now we can write our factors from the above table. Reading horizontally, first factor is 3x plus 4, so in a bracket 3x plus 4, and the second factor reading across horizontally will be the x plus 2. Solving for the roots, the solutions of the equation, we just take each of the above factors and equate them to 0. So 3x plus 4 is equal to 0. So rearranging, if I subtract 4 from both sides and divide by 3, then x is equal to negative 4 divided by 3 in this case, over my simple equation for x. And taking the second bracket, the x plus 2 is equal to 0. Again, solving that for x, I will subtract 2 from both sides, so x is equal to negative 2. So there are my solutions for my roots in this case, and we can see that negative 4 upon 3 is the first solution we were trying to find, and negative 2 is the second solution. Question B, we're given 5 is equal to 6x squared plus the 7x. Again, need to rearrange it to get all the terms onto one side, so I'll write that as 6x squared plus my 7x, and subtracting 5 from both sides, and that now equals to 0. So factors of 6x squared could be 6x and 1x, or it could be 3x and 2x. I think I will try in this case 3x and 2x. That's 6x squared, the factor of 6x squared there. And notice the constant is negative 5. Now that means the signs in the two brackets will be both a positive and a negative. Now I'm trying to make 7 in the middle. So now a factor of negative 5 could be negative 5 and 1, or a positive 5 and negative 1. That's the only factor I can have using whole numbers here. So I think I will try negative 5 on the top line and positive 1 on the bottom line. Let's try that first of all. So cross multiplying, 3x multiplied by 1 is 3x. And cross multiplying here, 2x multiplied by negative 5 is negative 10x. When I add them up, what do I get? I get negative 7x. Is that what I'm looking for in the middle of the equation? No, it's not. I'm looking for positive 7x. So that's not a correct solution, so I'll have to try again. So my second attempt, I think I'll make this positive 5 on the top and negative 1 on the bottom. Cross multiplying again, I will get 3x multiplied by negative 1, so negative 3x, and the 2x multiplied by the positive 5, so plus my 10x, and I can see now I've got my positive 7x here, so that is correct. So factors, so 3x plus 5 is a factor, and also the 2x minus 1 is a factor. Obviously I need to find the roots as usual, so to find the roots here I equate each of the factors here and solve. So 3x plus 5 is equal to 0. Solving that one, I will subtract 5 from both sides and I will divide by 3. So that gives x is equal to negative 5 divided by 3. And taking the second bracket, that will be 2x minus 1 is equal to 0. So rearranging, adding 1 to both sides and dividing by 2, x is equal to a half. And again, like I say, I've got the right values. X is negative 5 upon 3, shown here, and x is positive a half, and that's shown here. Finally, exercise 2F part C, we're given the equation of 20 minus 2x is equal to 6x squared. So again, bringing all the terms onto one side, I'm going to subtract 20 from both sides and add 2x to both sides. So I will form the equation of 6x squared plus my 2x minus 20 is equal to 0 as my starting point. I notice a common factor here. If I divide each of the terms by 2, I can simplify the numbers and still leave myself with whole numbers. So dividing throughout by 2, I will get 3x squared plus my x minus 10 is equal to 0. If you didn't notice the factor of 2, you can still solve with the 6x squared plus 2x minus 20 equation, but it gives you more complications in the solutions as there are more factors associated with the 6x squared than the 3x squared. Using my factorisation process, factors of 3x squared can only be 3x and the 1x, or simply the x. Notice the constant is a negative 10 here, so that means the signs in the brackets will be both different in this case. And negative 10, there are several factors there. I could use 10 and a negative 1, or negative 10 and positive 1, or I could use negative 5 and positive 2, positive 5 and negative 2. So quite a variety of factors that I could use here. Well, factors of 10 would be 5 and 2, but I need negative 10, so I need one of these to be a negative. I think in this case I will make the 5 the negative, and when I cross multiply, hopefully I'll get positive 1x. Go through the cross multiplication process. 3x multiplied by 2, that will produce 6x, and 1x multiplied by negative 5, that's negative 5x. Adding them up, that gives me positive x, positive 1x, and that is the middle term I'm looking for, positive 1x here. So I've got my factors. So my factors, reading horizontally across, that will be 3x minus 5. And again, second factor reading horizontally across, that will be x plus 2. Solving for the roots, so 3x minus 5 is equal to 0. So solving that for x, I will add 5 to both sides and divide by 3. So x is equal to 5 divided by 3. And taking my second bracket, x plus 2 is equal to 0, and again solving for x I will subtract 2 from both sides, so x is equal to negative 2. So those are my roots there. So x is equal to 5 upon 3 we can see is correct in the answers, and x is equal to negative 2 we can see is correct. Okay, there's a solution then to exercise 2F parts A, B and C. Here's some tutorial exercises for you to undertake using factorisation. With the question 1 here, there are 6 little sub-questions to solve for here. We've got to determine the factors first of all, and then the roots. I encourage you to stop the presentation here and attempt these questions. The answers are shown on the following slide. So question 1, here are the answers, all obtained using factorisation, so the factors are shown here and also the roots. Here are some further tutorial questions. If you want to attempt these, again try and solve using factorisation, find the factors and then find the roots. The answers are shown on the following slides. Here are the answers to the question on the previous slide. The factors are shown for questions 1 through to 20, and the roots are shown for questions 1 through to 14. Now let's review solution of quadratic equations using the quadratic formula. So we're going to solve equations again of the form ax squared plus bx plus c is equal to 0, but using the formula shown on the right hand side here. The formula states that the x, the roots, are equal to negative b plus or minus the square root of and b squared minus 4ac, all divided by 2a. Formula is given without proof, but it can be obtained from using the calculus. Just some general comments on formula usage here. Just considering the term under the square root here. If the b squared is greater than the 4ac term, then the roots can be calculated and they're different, they're unequal. If the b squared term under the square root is actually equal to the 4ac term, then calculating that will give a value of 0, and in that case the roots will be the same value. But if the b squared term is less than the 4ac term under the square root, we end up with a negative value, and you cannot find the root of a negative number. The solution in that particular case will be termed complex and is outside the scope of this presentation. There is another presentation related to complex numbers which looks at solutions to these kind of problems, but they will not be considered in this presentation. Note with this quadratic formula, there's no factorisation required. We are directly solving for the roots. We're finding the values of x directly from the formula. On the following slides, we'll show how the formula is used. Example 1e, we're asked to find the roots of the quadratic equation given of x squared minus 4x plus 3 is equal to 0. Now whenever we're solving the quadratic equation, we know it must be in the form of ax squared plus bx plus c, so this is my ax squared term plus my bx plus c is equal to 0, so straight away we've got it in the appropriate format we need to solve our problem. All we do with the quadratic equation is literally read the information from the question. So in this case, my a value is positive 1. There's a 1 in front of the x we don't write, but it's positive 1. My b value in this case is negative 4. Be careful you take the negative with you. And my c value is positive 3, so positive 3. So just simply reading off the a, b and c from the equation that's in the format of ax squared plus bx plus c equals to 0. All we do now is put those values into the equation. I repeated the equation here on the right hand side for x. So x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. What I'm going to do now is insert the values of a, b and c into the equation. So the equation starts with negative b, so b in this case notice is negative 4, so I'm going to start with a double negative here. I've got a negative b, that's negative a negative 4. My b is negative 4, and that's plus or minus the square root of b squared, so b then negative 4 all squared. I don't really need a negative there because when you square a negative number you always get a positive, but I've written it in for completeness here. So that's my b squared. And then I subtract from that the 4 multiplied by a, and a in this case is 1, so 4 multiplied by 1, that's my a. And then that's multiplied by c, and c we said was positive 3, so there's my c value, and there's my positive 3. And it's all divided by 2a, and a we said was 1 in this case. The rest of the process is purely arithmetic. We just have to be very careful how we evaluate our questions, alright? So be very careful. If you are squaring a negative number, don't forget it always becomes positive. Some students seem to miss that, but that would be negative 4 squared is positive 16 inside the bracket, and negative 4 multiplied by 1 multiplied by 3 would be the negative 12 shown here. Be careful at the front of the equation, the double negatives, we've got a negative and a negative 4 here, so that becomes positive 4. So be careful of that. Sometimes students forget the negative at the front of the equation. But the rest of it is purely arithmetic. We're just going to evaluate the numbers here. What we'll end up with is, in this case, an equation with 4, and don't forget we've still got the plus or minus in the equation, so 4 plus or minus 2 in this case it will be divided by 2, and that's where we get our two solutions from. We get a 4 plus 2 divided by 2, so that gives a value of 3, and we will also get here this solution with the 4 minus 2 divided by 2, and that gives us the other root of 1. And we can see the roots on the graph is plotted for convenience. We can see that the curve crosses the x-axis at positive 3 and also at positive 1. So those are our roots in this particular equation. And don't forget the roots are the solutions to the problem. We're trying to find the x values. Question 2e, very similar approach here, just that they've changed the variable. We've got the quadratic equation, 2t squared minus 5t minus 4 is equal to 0, but just read the x for t in this case. Again, it's of the form ax squared plus bx plus c, so we just simply read off our numbers. So in this case, the a is positive 2, so there's my positive 2. The b in this case is negative 5, so there's my negative 5. And my c in this case is negative 4, so there's my negative 4. And again, it's just a question of putting those values into the equation and solving. In this case, of course, we're solving for roots of t. So we find that t is equal to 3.138 and t is equal to negative 0.6375. And therein lies the reason why we use the quadratic formula. We could not factorize to solve for these roots. That would not be possible because of the values here, they're real numbers, so it's not possible to solve. So the quadratic equation is used to solve situations such as this. We can see those roots look reasonable from our graph. This was like the root of 3.138, and here's the root of negative 0.6375. So again, as always, we're solving for the roots. Tutorial questions using the quadratic formula here. Question 6, we're asked to solve the equation given here, which is in the correct format to solve. Question 7, we're asked to solve for the roots here of v. The variable is v, not x in this case. Slightly more complicated equation here to rearrange, but basically get all the terms onto one side of the equation and then solve for v. I suggest you stop the presentation, attempt these questions, but the work solutions are shown on the following slide. So question 6 solution here, we're given the equation 6x squared minus 8x minus 10 is equal to 0. That is of the form ax squared plus bx plus c is equal to 0. So we've got our standard form straight away, no rearranging required. So reading from the question, I can clearly see that a in this case is equal to 6, b in this case is equal to negative 8, be careful you take the negative with you, and then c is equal to negative 10. What I'm going to do now is put those values into the quadratic formula shown on the left hand side here. So x is equal to negative b, be careful of the double negatives here, because b in this case is negative 8, so that's a double negative, plus or minus the square root of, again b, I don't need to put a negative in here because when I square a negative I get a positive, so I'm just going to write it as positive 8 squared minus 4, and that's multiplied by the a, which is 6, multiplied by the c, which is negative 10. And don't forget the whole equation, everything is divided by 2 multiplied by a, and a in this case is the 6. So evaluating, we get 8 plus or minus the square root of 64, which is the 8 squared, and we're subtracting from that negative 240. Be careful, 4 multiplied by 6 multiplied by negative 10 is negative 240. So we're evaluating further, that's 8 plus or minus the square root of 304 divided by 12. Square root of 304 is the 17.436, the 3 decimal places. So 8 plus or minus 17.436 divided by 12. Now we can find the roots of the equation. So x is equal to 8 plus 17.436 divided by 12, which is 2.12 to 2 decimal places, and x is equal to 8 minus the 17.436 divided by 12, which is equal to negative 0.79. Those are our two solutions. Don't forget this plus or minus in the original equation must follow through the calculation all the way through here. You mustn't lose that. So when we come to the final calculation of the roots, we've got a plus and we've got a minus in our solution. So that's how we get the two roots here. So 2.12 is the first root and negative 0.79 is the second root to the solution. Now question 7, we need to be slightly careful of this in the format of the question. We're given that v squared plus a half, I'll write it as 0.5, some students prefer the decimal, so I'll put it as decimal, is equal to 4v. We need to get all our terms onto the same side of the equation, so I'm going to subtract 4v from both sides. So v squared minus 4v plus the 0.5 is now equal to 0. We've now got the form of ax squared plus bx plus c is equal to 0. So in this case the a is equal to 1. We've got the 1v here. B is equal to -4 and C is equal to 0.5. So now it's just a question of putting those numbers into the equation, but this time of course we're actually solving for V. So in this case V will equal to the negative B, so that's negative the -4, plus or minus the square root of the B squared, so 4 squared minus 4 multiplied by the A, which is 1, multiplied by the C, which is 0.5. And of course it's all divided by, in this case, 2 times A, so that's 2 multiplied by 1. I'm going to let you go through the arithmetic. Don't forget you're finding V here. What you should end up with is V is equal to 3.87 to 2 decimal places, and the second root, the V is equal to 0.13 to 2 decimal places. So those are the roots you should end up with. But I'll let you do the calculations in your own time. I will leave you with some further tutorial questions related to use of the quadratic formula here. So try and solve all of these using the quadratic formula. Be careful, not all of them in the correct format to begin with. For example, I can see question 3 needs to be rearranged, question 4 and so on. So be very careful of that. I would encourage you to stop the presentation and attempt these questions now. Don't worry too much about equations 16 through to 20, they are becoming particularly difficult here, but I thought I'd leave them in case some of you do want to attempt these kind of questions, but a bit more manipulation involved with those kind of questions. All the answers are shown on the following slide. Here are the answers for questions 1 through to question 20. Here's the bibliography that was used to help generate the presentation. And I hope this has been of interest to you, and thank you for viewing.